Suppose we have a piecewise defined function that is defined as x plus 2 if x is less than or equal to negative 1, and then x squared if x is greater than negative 1. So basically then what we're doing is we're breaking the domain up into two parts, the part that's to the left of where x is negative 1 and the part that's to the right. Over here, x is less than or equal to negative 1. And if we were to make a little t-chart here, where we would normally put x and y, we'll put here that x is less than or equal to negative 1 to remind us that the only x values we're going to put in this column here will be things that are less than or equal to negative 1, like negative 1 and negative 2. And y will be defined as x plus 2 for that part. So in other words, we'll take the x value and add 2 to it. So minus 1 plus 2 is 1, and minus 2 plus 2 is 0. So we would have a dot at minus 1, 1, and a dot at minus 2, 0. And this line makes sense because what's described here, if we were to define the function this way over the whole domain, is that we would have a line that would hit the y-axis at positive 2. But it does stop here, and by the way, that would be a filled-in dot because we are including negative 1 in this part of the domain. Now over here to the right of where x is negative 1, we would have, again, if we make a t-chart, we'll put x bigger than negative 1 here to remind us that when we put these values of x in here, there will be things like 0 and 1 and 2, things that are greater than negative 1. And then if we were to find our y values, we would do that by squaring the x values. 0 squared is 0, 1 squared is 1, 2 squared is 4. So we would have dots like 0, 0, 1, 1, and 2, 4. And we expect this kind of a shape because we know that y equals x squared makes a parabola. Now, this parabola would tend back up this way and connect up with this dot for this part of the graph, because this gap in here between where x is minus 1 and 0 falls under this part of the domain here where x is bigger than negative 1. So this x squared graph would continue all the way up here. We would have a filled-in dot here. In other words, if we put minus 1 in for x, and we would get 1 for y if we square it, we have a filled-in dot here because it's part of this line here. If, though, all we were graphing was this part here where x is greater than negative 1, for the parabola we'd have an open hole. But because the graphs connect here and because the function is defined as having a function value of 1 when x is minus 1, it is in fact filled in there because they connect.